everybody, it's me Fadi, and welcome again to another episode of how to build and maintain a reef aquarium. Today I'll speak about the different water parameters and how to test them and maintain these parameters in our reef aquariums. In this video I'll start by talking about the different parameters, elements and chemical compounds, comparing values that we target in our reef tanks to values in natural seawater, and finally how to test and which test kits I use to test tank parameters. Saltwater contains many elements and compounds, and there are some important elements you need to test and maintain stable at a certain range. These different parameters and elements are crucial to create the ideal environment that mimic parameters found in natural seawater. And here are some of the parameter values in natural seawater and the range we try to maintain in our reef tanks. Maintaining the calcium level is one of the most important aspects of keeping a reef aquarium. Corals use calcium to form their skeletons, which composed primarily of calcium carbonate. The corals get most of the calcium from the water surrounding them. Calcium often becomes depleted in aquariums housing rapidly growing corals and clams. Like calcium, corals also use carbonate to form its skeleton. To ensure that the corals have the needed supply of carbonate and bicarbonate for calcification, we test for alkalinity. Alkalinity is the capacity of the water to resist changes in pH that would make the water more acidic. In normal seawater or marine aquarium water, the bicarbonate greatly dominate all other ions that contribute to alkalinity. Therefore, it's more convenient to test for alkalinity instead of carbonate and bicarbonate. Alkalinity maintenance is critical for keeping a reef aquarium. Alkalinity will rapidly drop as corals uses up much of what is available in the seawater. Most aquarists try to maintain alkalinity levels at or slightly above natural seawater at the range of 7 to 11 dkh. I usually keep my tank at 8 to 9 dkh. High levels of alkalinity will increase the precipitation of calcium carbonate on objects such as heaters and pump impellers. This precipitation will not only waste calcium and carbonate, but it will also increase equipment maintenance, and this equipment may fail of this precipitation. In addition, elevated alkalinity may depress the calcium levels. Salinity is the saltiness or amount of salt dissolved in a body of water. Salinity is measured by ppt, or parts per thousand, or basically how many grams of salt dissolved in 1 kilogram of water. We can also use specific gravity to measure how much salt in the water. Specific gravity is the ratio of the density of salt water relative to the density of the same amount of fresh water. Natural seawater have the salinity of 35 ppt, or a specific gravity of about 1.0264. Remember, the most important thing for your aquarium is consistency and stability. This applies to both the salinity and the elements within the salt. Any changes in salinity, salt brand, or other parameters should be made gradually. Top up evaporated water regularly, or fit an auto top-up system to reduce swings in salinity to a minimum. Now let's talk about pH. Many aquarists spend a considerable time worrying about pH. Some of these efforts can be justified, as a true pH problem can lead into poor aquarium health. In many cases, the only problem is with the wrong interpretation of the pH value. Natural seawater pH is from 8 to 8.3. Reef aquariums can succeed in a wider range of pH. In my opinion, a value from 7.8 to 8.4 is acceptable. It's better to keep it stable with 0.2 difference between day and night. There are some aquariums, especially that runs calcium reactor, that have a pH range from 7.8 to 8. While calcium reactor tends to lower the pH, it keeps the alkalinity stable. In this case, any problems associated with calcification at these lower pH values may be offset by the higher alkalinity. On the other hand, high pH have its own problems, which is the precipitation of calcium carbonate, resulting in a drop in calcium and alkalinity and the clogging of heater and pump impellers. Usually, the pH is higher when the lights are on and tends to go down when the lights are turned off. To minimize pH fluctuations between day and night, you can run your aquarium main light and fuge light on alternating cycles. Also, if the pH is dropping too much, you can install CO2 scrubber on the skimmer air intake to minimize the amount of CO2 going into the aquarium. Some calcium reactor users use CO2 scrubbers to minimize CO2 pH lowering effect. CO2 affects the pH values, so if you are struggling with low pH, that means that there is too much CO2 in the water. Not enough flow and water movement may be the cause here. Magnesium primary importance is keeping the balance between calcium and alkalinity. Seawater and reef aquarium water are always supersaturated. Magnesium binds to the surface of the calcium carbonate crystals and stops the precipitation. Without the magnesium, you can't keep calcium and alkalinity at recommended value. And we target natural seawater magnesium levels at 1250 or 1350. Corals and coralline algae may deplete magnesium as they sometimes can use it in building their calcium carbonate skeletons. Many methods of supplementing calcium and alkalinity may not have enough magnesium to keep it at recommended levels. Magnesium should be measured occasionally. Tanks with excessive calcium carbonate precipitation on heaters and pumps might suffer from low magnesium levels along with high pH, calcium and alkalinity. Phosphate is usually introduced by fish food. If it allowed to acclimate and rise above natural level, it will have two unwanted effects. The first one is the reduction of corals' calcification, potentially stunning their growth, and the second effect is the growth of unwanted algae. Many resources suggest that phosphate must be kept at not higher than 0.03 ppm. However, I feel my corals are doing better at 0.1 ppm. The best way to have low levels of phosphate in our aquarium is to use a combination of several phosphate export methods. Growing and harvesting macroalgae in our refugium, using food without excessive phosphate, skimming and using phosphate binding media like JFO. Ammonia is toxic for all animals, fish, corals and invertebrates, and ammonia should be always at zero. In an established aquarium, all the ammonia produced is taken up rapidly. It's used by different algae in addition to bacteria that will consume the ammonia and convert it to nitrate and nitrate. And we talked about the nitrogen cycle in our aquarium in episode number 5. Tracking the nitrate is only helpful while start cycling the tank. I don't bother with testing nitrate in an established aquarium. Nitrate is the end product of the nitrogen cycle, and with high value, it will encourage algae growth. Also, many resources say that nitrate should be less than 0.2 ppm. In my case, I like nitrate values at 5 to 10 ppm. There are many ways to reduce nitrate, including reducing the tank nitrogen input by proper feeding methods and a clean RODI water. Increasing nitrogen export by skimming, growing and harvesting algae in a refugium, dosing products like AZNO3 and Red Sea Nopox. Of course, there are many elements and compounds in seawater that we didn't talk about. Today we talked about only the important ones. There are many different ways to test for the different parameters. For testing salinity, some people use hydrometers, but I don't recommend using hydrometer because they are not accurate. The most reliable way is to test salinity or specific gravity by a refractometer. Refractometers work on the principle that changes in salt concentration affect the reactive index of light, and therefore light entering the instrument is deflected by varying amounts into a graduated scale. Refractometers are convenient, fast, and reliable method to test for salinity or specific gravity. Refractometers available in the aquarium industry can be manual or digital. Manual refractometers are affordable and easy to use. Digital ones are easier to use, but they are a little pricey. To use a refractometer properly, we must follow the correct calibration procedure. Every refractometer will come with its own calibration instruction. For the other parameters, there are many test kits to use, like Salifert, Red Sea, Neos, and many others. I like to use Salifert test kits to test calcium, alkalinity, and magnesium. I feel that Salifert is the most accurate and easy to use compared to other brands. To test phosphate and nitrate, I like to use Red Sea. They have this color wheel that you can use to match the test colors. I also like Neos phosphate and nitrate test kits. There are also digital testers like these HANA testers that we use to test phosphate. And recently, automated testing and reef bots started to be available for the aquarium industry, like the Neptune Trident and the Reef Kinetics Reef Bot. The Neptune Trident, which I run on my tank, give me an automated reading of calcium, alkalinity and magnesium, as these are the three important parameters for keeping corals. The Trident will schedule these tests for you and you can see the results on your Apex Fusion. In addition, you can configure your dosing pumps to dose calcium carbonate and magnesium to your aquarium if they are running low. The Reef Bot by Reef Kinetics is an automatic water testing device that monitors your aquarium by running tests and sending you real-time updates via mobile or web app. What's great about these Reef Kinetics that you can use many test kits and fill the reagents inside special vials inside the Reef Bot. The ultimate testing method is ICP testing, like what Trident and some other companies provide. So you mail in a sample from your aquarium water and they will perform testing for all water parameters and send you an online testing report. I see it very helpful to send samples of your water to ICP testing every while and then to check on overall status of your aquarium water. This is very helpful if you are facing some issues and you don't know what is the problem and what is the cause of these issues. A helpful thing is the report that they give you with color indicators, red, yellow, green, in addition to recommendation to fix any issues. And this is my testing schedule and parameters target values I like to maintain in my reef tank. That's it for today. Next week, I'll talk about how to supplement calcium, alkalinity and magnesium and other trace elements. Thanks for watching and don't forget to subscribe and like, and see you soon in the next episode.